and encounters resistance at the weld tip interface and at the part interface. Resistance to the current at the part interface creates enough heat to melt the metal and cause a weld nugget to form. When the weld gun closes, the weld tips contact the metal and squeeze them together. The metal is squeezed for a short time to make sure that the weld gun is fully closed and that the full weld tip force is achieved. This is referred to as squeeze time. A squeeze time of about 12 cycles is used for small weld guns, and 25 to 30 cycles are used for larger weld guns. When the squeeze time is complete, electric current begins to flow through the metal from one weld tip to the other. The duration of the current flow is referred to as weld time. The current generates a lot of heat when it encounters the resistance at the part interface, and a lesser amount of heat at the weld tip interface. The heat at the weld tip interface is conducted away by the water-cooled weld tips, while the part interface continues to get hotter and hotter. About halfway through the weld time, the metal at the part interface begins to melt, then a weld nugget is formed. When the weld time is complete, the current stops flowing. Then a hold time of approximately 4 to 5 cycles is used to give the weld tips enough time to absorb heat from the outer perimeter of the weld nugget and cause it to harden before the weld tips open. A weld nugget should be as wide as the weld tip that contacts the thin metal and penetrate to between 20% and 80% of the metal thickness. This is referred to as a setup nugget. To produce setup quality weld nuggets, you need to understand how resistance welding is affected by weld tip alignment, weld tip force, squeeze time, weld tip size, weld current, weld time, weld tip cooling,